Today we're talking about the correlation coefficient and how to find the line of best fit on a calculator. So first up, correlation coefficient goes from -1 to +1. Over here you see strong negative correlation. Some points are pretty close together. And if points get a little more spread apart, then our correlation is not as close to -1. Here, the points are all spread out, and so it's a correlation of 0. And then as it goes up, that's a positive correlation, but it's weak. And this is a strong positive correlation because the points are really close together. So the correlation coefficient R, and it goes from -1 for strong negative to +1 for strong positive. So now on to matching. We can draw some lines of best fit in to represent kind of how the data is moving. I'll do my best. This one's negative. Okay. So these two appear to be pretty strong. These two are pretty weak. This is our strong positive. So over here, our number that's the strongest positive would be 0.80. Okay. This one is a strong negative, so our number over here that's the strongest negative is -0.76 because it's closest to -1. Now on to this one. This is our weak positive. So that's this one, positive. It's a positive number, but it's not as close to +1. So weak positive, that would be the 0.43. And then lastly, our weak negative is going to be this one because it's pretty close to 0. And that's going to be R equals -0.14. Cool. On to the last section here, which is looking at graphs and then saying what the correlation is and if there's what a possible R value would be for each. This one is scattered all about. There's no real order to it. This is no correlation. So the R value would be 0. This one is negative, but I would say it's pretty weak because the points are pretty far away from the line. So a weak negative. So let's do -0.5 as a possible R value. And then lastly, this one is I'll say pretty strong positive. It's not the strongest positive, so I don't want to go all the way to +1. It's not weak though, so I'm going to choose somewhere in the middle, like 0.75. So say strong, pretty strong, strong-ish. Positive 0.75. Okay, so that's correlation coefficient. We need to know that because in a second we'll teach you how to find it on a calculator. So moving on to on the back, how to find the line of best fit on a graphing calculator. We're going to find the line of best fit for this data down here. And what we're doing is finding the equation of a line. That's basically so here's an example of a scatter plot. You put your data on your scatter plot, and then you can draw a line of best fit through it, and you need to find the equation of that line in y equals mx plus b. On MathXL, how'd you do it from multiple choice, but you can actually do it in your calculator, which is pretty great. So if you have a calculator like this, then you should be able to do this at home. You turn it on, and you want to go to Stat. So that's right here. You see it right there. You see the scatter plot actually right there. So key over to Stat, and then you want to click EXE to enter. So I'm going to set this down now. Mine actually has a bunch of data already in it, so you need to delete out any stuff that's in there. So highlight the first number and then just delete till it's gone. I'm going to go over right, delete anything in list 2. Okay, and now we're going to type in these numbers into our data table. So latitude will be my x and temperature will be my y. In other words, we want to put x in list 1. So here's my list 1, and I'm going to type in all of my x values. So 0, and then exe. 10, enter. Exe is enter, by the way. 20, enter. 30, 40. I'm looking at this list, so you can do the same. Okay, all the way up to 80. Now in list 2, I'm going to put my y values, which are my temperatures. And you should be able to follow along on your calculator. 79, 81, 79, 68, 58, 43, 28, 13, and 1. If you do it right, then you should have the same amount of values in both your list 1 and list 2. Okay, now onto these buttons. We're going to calculate the line of best fit. So right here it says calc. So I'm going to click calculate, F2. The regression, F3. In terms of x, F1. In terms of, we want ax plus b because it's going to give us mx plus b. And there you go. So this is our line of best fit. Negative 1.07, the a value, that's your slope. Why it's a, I'm not really sure. Negative 1.07x plus b is still the y-intercept, so 92.87. The correlation coefficient is r, which in our case is negative 0.969, so we'll do negative 0.97. Based on this correlation coefficient, my correlation is strong, negative, because it's really close to -1, which means that as the latitude goes up, then temperature is going down. So as latitude increases, temperature decreases. And then lastly, estimate the average temperature for a city with a latitude of 48 degrees. You're going to take your equation, and latitude of 48 will go for x. So I keep my equation the same, but instead of putting x, I put 48. And then I'm going to go ahead and do this in my calculator. So you can exit to get out of this screen. And then to get out of the stat, you click on menu, and we're going to go back to run math, exe, and you can type this in. So negative 1.07, and in parentheses, 48, close the parentheses, plus 92.87. 41.51 degrees would be my temperature if it has a latitude of 48.